Assalamualaikum and good day to everyone. My name is Nur Kristina binti Muhammad Lukman and my metric number is S65534 and I will be presenting to you about Autotransformer. My explanation is divided into the overview, the windings, the terms, the voltage and current relationship, the apparent power rating advantage, the internal impedance, and lastly the application. So first, what is an autotransformer? Autotransformer is a special purpose transformer that is used to change the voltage level by a small desirable amount, and it is cheaper than a conventional transformer with two full windings. Talking about the windings, how about the windings of the autotransformer? First, the autotransformer is divided into two, which is step up and step down. Let's get more details into that. The first winding of the autotransformer is connected in additive manner to the second windings. The first winding is called the common winding and the second one is called as series winding. It is called as common winding because the voltage appears on both sides of the autotransformer, and it is called as series winding because it is connected in series with the common winding. Moving on to the terms, at the common winding, we have common voltage, common current, and number of turns at common windings. And at the series winding, we have the series voltage, series current, and number of turns at series windings. Autotransformer has two sides, which are high voltage side and low voltage side. High voltage side, we have high voltage and high current, and low voltage side, we have low voltage and low current. At the step-up transformer, Vin is equal to common voltage, Vout is equals to common voltage plus with series voltage. Low voltage is on the primary side. For the step-down transformer, Vin is equal to common voltage plus series voltage and Vout is equal to common voltage. For the step-down, high voltage is on the primary side. For the voltage and current relationship, we have that the ratio of the common voltage over the series voltage is equal to the number of turns in common windings over the number of turns in series winding, and it is opposite for the current. Combining the low voltage side and the high voltage side with the number of turns, and we can get the equation is like this. And it is also opposite for the current, and we can get the equation like this. Moving on to the apparent power rating advantage, which is the autotransformer can handle much more power than the conventional transformer. As I state here, the apparent power to autotransformer is S10. Input power is at the low side and the output power is at the high side. Input power is equals to output power and can be denoted as S10. Next is the apparent power to the transformer winding SW. Power winding is equal at both sides, common windings and the series windings. It can be related with the low side and the high side, and the equation can be twisted until we can get the ratio between S10 and SW relating to the number of turns. What is S10 and SW? S10 is the apparent power entering the primary and leaving the secondary of the autotransformer, while the SW is the apparent power that actually traveling through the transformer windings. To be more clear, the explanation of the equation above shows that the closer the two voltage are, the greater the autotransformer power advantage, and the smaller the series windings, the greater the advantage of the apparent power. Autotransformer would have more apparent power compared to the conventional transformer that has the same windings. Then autotransformer can be used as variable transformer. There is some disadvantage for the autotransformer, which is that it experiences electrical isolation loss since there is a direct physical connection between the primary side and the secondary side. Autotransformer has some problem with the internal impedance. The effective per unit impedance of an autotransformer is reduced by a factor equal to the inverse of its power advantage. Means that if the power is N, the internal impedance is equals to 1 over N. The higher the power, the lower the internal impedance. But internal impedance is important to limit the current flows during the short circuit. Autotransformer has many applications in our daily life, but I will state 4 of them. First is motor starter. It can be used to reduce voltage supply to load during the starting period. Second is for testing. It is for apparatus testing in lab for the voltage stabilizer. It can compensate the voltage drop in transmission or distribution lines. And lastly, for the speed control for fan. It can adjust the speed from the change of the voltage. I think that's all from me. I hope you will be more clear about autotransformer. Thank you.